Hi, I'm Jenny Gendron of Altera. Are you ready to make some music? We've got a low-cost, low-power CPLD development kit that will let you play some musical notes. Well, maybe not enough for a hit song, but it's still a fun way for you to evaluate the board's ability to drive analog devices. The MAX V CPLD development kit gives you a closer look at our newest low-cost CPLD family, the MAX V series of devices. These CPLDs provide robust features at up to 50% lower total power compared to competitive CPLDs. In this video, we'll show you how easy it is to use the kit to try out various MAX V capabilities. We hope you'll see how the CPLD can meet your performance, price, and power requirements, and enjoy playing a few notes in the process. Before we go to our demos, let's start with a few basics on the MAX V CPLD development kit. Priced at only $74.95, the kit lets you evaluate the MAX V CPLD and prototype your CPLD applications. And you can order it now. The board has a MAX V CPLD in a 256-pin FPGA package. The kit also comes with free Quartus 2 Web Edition design software, an embedded USB blaster, a Type B USB port, as well as clocks, multiple expansion connectors, memories, and more. Now let's run through our demos. I've got my board connected to the PC via the USB cable that ships with the kit. First, we'll open up the board test system, or BTS, and take a look at the different functions. As you can see, the BTS is like a dashboard, and the tabs here represent the various design examples that ship with the dev kit. You'll see that some of these tabs are grayed out. This means that you'll need to download those design examples into the CPLD. Our musical notes example is one of the grayed out tabs. So let's go ahead and download it into the MAX V CPLD now. You can use the configure menu in the BTS, but today I'm going to use the Quartus 2 programmer to download the design example to the device. I'm going to launch the Quartus 2 design software and open the Quartus 2 programmer. I'll go ahead and delete the existing design and add the speaker design example. I'll check the program configure box and hit start to download the design to the MAX V device. As you can see from the progress bar, the download was successful, so I'm going to go ahead and close the programmer and open up the BTS again. The speaker tab is now active. This function really provides a fun way for you to see how the board can interface to and drive analog devices. Here on the board, we have a 4-pin header, and we have our own speaker with the 4-pin connector to connect to our board. We can play a few notes like this. When we increase the frequency for different notes, we're using the onboard oscillator. When we increase the volume, we're tapping into the I/O strength of the CPLD. Pretty cool, huh? Now we're going to measure power consumption, which is another simple function of this dev kit. In the Power tab, you'll see fields that can fill in for VCC internal power and for VCC I/O power. You'll need to use your own digital probe to get these values. I'm going to go ahead and probe the board here to get the VCC internal power numbers and enter them into the GUI. Now I'll probe the board to get the VCC I/O power numbers. I'll go ahead and hit calculate. And you can see that the VCC internal power is a little over 9 milliwatts, and VCC I/O power is almost 6 milliwatts. The MAX V CPLD can also be used as a power management controller. On our kit, the onboard LEDs can serve as a proxy for another chip in your design. And we can use the MAX V CPLD's internal oscillator to monitor the status of another chip, or to turn it off after a specified period of inactivity. When the other chip is on, the onboard LEDs light up, and when the chip is off, the LEDs go dark. In this design example, I'm going to tell the device to turn on the LEDs after 2 intervals. I'll enter 2 into the box here and hit start. We'll see the LEDs go off, and after 2 intervals, both LEDs will turn on. There are also a few other functions built into the dev kit that perhaps aren't as flashy as what we've already covered, but are just as useful. GPIO, or General Purpose I/O, shows you the number of user LEDs and push buttons available. We can see here that we've got 2 user LEDs, 2 push buttons, and 1 cap sense button. This is the default design that ships with a dev kit and is preloaded on the MAX V device. UFM, or User Flash Memory, allows you to access the flash memory inside the MAX V device, so you can read or write to specific memory addresses. The Oscillator tab. Here you can use an external oscillator to measure the internal oscillator to assess its accuracy. And finally, with the EEPROM tabs, you can install your own EEPROM and use the read, write, and erase capabilities on the non-volatile memory source. We hope these demos have given you some ideas on how you can take advantage of the capabilities in the MAX V CPLD development kit. You can buy a kit at altera.com/MAX5 DevKit. And you can learn more about MAX V CPLDs at altera.com/MAX5. I'm Jenny Gendron, and on behalf of everyone here at Altera, thanks for watching.